We will apply. In previous class, we discussed about different RLC series parallel circuits with AC excitation. So in today's class, so we will apply loop current method and node voltage method for AC circuits. So this is known as steady state analysis, right? So we assumed that the inductor is saturated and the current is in steady state and the capacitor current is in steady state. We will discuss more. So what is exactly that steady state and what is transient. So, and moreover, the source transformation, so whatever we discussed, so that is also applicable for this AC circuits. So for example, you have a circuit something like this. Say let us assume this is 6 ohm and this is J3 ohm and this is 5 ohm. Right. So this is the circuit. So we have this current source in parallel with some impedance, right? So this is current source and its value is 4 at an angle minus 35 degrees. So this is amperes. So we can convert this into its equivalent. We can convert this into its equivalent voltage source. We can convert this into its equivalent voltage source, right? So how it will be? It will be something like this, right? Agree? So these two are identical. Okay. So what is this value? What is this value?
24 at angle of minus 35.
24. No, what is this angle? This voltage? So you know source transformations, right? So how to convert voltage source into current source and current source into voltage source? You are aware of that? We already discussed it, right? So for example, this is 3 amperes and say this is 6 ohm. So this we can convert into its equivalent. Right? So what is this value here?
18, sir.
It's 3 and 18 volts, right? And this value is
6 ampere. 6 ohm.
6 ohm, right? Similarly, you tell me what is this here? What you will get?
24 volts.
Why 24 volts?
No, sir.
24 volt
Distance
at
into
minus
current.
35 degree.
So this entire thing is in parallel, right?
Net resistance into current, sir.
So what is its equivalent value? 6 into
5 plus 3, J3.
J3, right? So what is that combination? What is that combination?
Parallel.
In polar form? What is this combination in polar form?
I get 6 into 5 plus 3j upon
6 into
11
5
plus
plus
3j.
J3 by 6
What is
in
the polar
6,
form?
7 plus J3. Yes,
R
sir.
plus J R at an angle theta form. How it will be? R at an angle theta form.
Sir, 1 by R1 square plus 1 by R2 square. Sir.
What is the exact value? Tell me. 6 parallel with 5 plus J3. Okay, if you calculate that, right, so it will be 3.07 at an angle 15.7 degrees. Okay, so that means this is equal to 3.07 at an angle 15.7 degrees, right? Agree? So now
Yes,
what
sir.
is this value? So now it is 4, this current source, right?
12.28.
So 4 minus 35 into 3.07 at an angle 15.7. Right, if you multiply these two, so 12.3 at an angle. So sum of these two,
Minus
minus
19.3.
plus minus 19.3.
3.
This is volts. So how to give the sign? How to give the sign? So here in general for AC there is no signs, right? Because the waveform, sometimes you have positive off cycle and sometimes you have negative off cycle, right? But when you're calculating that, when you have multiple sources are there, so we usually mention with polarity. So that means that gives you the instantaneous polarity, right? So that means we have plus. So that means at this instant, so if this is positive, this current is leaving, and at the same time, so this is positive. So this gives you the instantaneous polarity of this voltage source. For example, you have multiple sources are there. So in that case, if this is exactly positive, at the same time, maybe it will be something like this. Right. So this is positive, this is negative. Or in other words, this terminal is positive. So meaning is at some instant, if this is positive, means at the same instant, so this is positive. This other terminal is positive. That means this is negative. Okay, so that gives you the instantaneous polarity of AC source. Okay. So if this is positive at the same instant, so this other terminal is positive. That means clear. So
Yes, sir.
generally for AC there is no polarity because it is continuously changing from positive off cycle to negative off cycle, but it has instantaneous polarity. So that means when relative polarity with the other sources. Right. So at instant, the current is leaving here. This the current is flowing in this direction, right? So that means at the same instant, the voltage is like this. If it is in the other way, instead of that, in this you'll get minus plus sign here. So this will be the minus sign. That's the difference. Clear? So this can also be applied for voltage source. For example, you have voltage source something like this, a dependent voltage source. Say this is 3 ohm and this is minus J4 ohm and this is 3I volts. 3I volts. So how to convert this into its equivalent current source? So this is a dependent voltage source, right? So that means this will be a dependent, this is dependent voltage source. So that means we can convert this into dependent current source. Again, if this is a current source, so we have this impedance here. So this is plus minus, right? So obviously this will be the arrow direction. Agree?
Yes, sir.
So what is this value here?
3I by 3 minus J4.
3I by 3
3
minus
minus J4.
J4. Okay. And this value is 3 minus J4. So this is amperes, right? Clear?
Sir, here I
Yes.
stands for
Somewhere in the circuit, yeah, that we are discussing, right? So this I is somewhere in the circuit. Okay. So this I is somewhere in the circuit. Okay. So remember when you are applying source transformation, so when you have dependent sources, so you have to make sure that, so this is not the I. Okay. Because we are altering the circuit. So this I or this wherever it is dependent value, so that is from the other portion of the circuit. Okay. So then only we need to apply the.
sir, 3I is not the current.
So the 3I is not the current. So 3I is the voltage. Okay. So this I is there, right? So this I is somewhere in the other portion of the circuit. Okay. Clear?
Yes, sir.
Okay, right. So this is how we will apply source transformation. But the thing you have to remember that when you are applying the source transformation, for example, something like this. So this is the problem. This is dependent source is there. Okay. So this is for I, for example, this is for I. So that means this is I here. So in this particular case, so you cannot apply source transformation because so this is depending here, right? So you have to make sure that say that portion is somewhere in the other portion of the circuit. So if this is changing, so automatically the rest of the circuit is changing, right? So you have to you need to avoid. Yeah, that's a particular case when you are applying source transformation for dependent sources.
Sir, could you repeat once again why we can't apply source transformation in the previous question?
So here this I is here, right? Okay, so this is the I, that is the current that flowing through the circuit. So based on that, so this current is depends, right? Agree?
Yes, sir.
Okay, but when you're changing, you're altering the circuit, right? So you're altering the circuit, so you cannot say this is I. So why you cannot say this is I? So because it's a combination of these two. You agree?
Sir, sorry, I
Right,
didn't
now
get that
this,
one, sir.
this
I
I
didn't get that
is,
one.
this value is varying, right? So earlier this is I, but so now after source transformation, you are modified this circuit. So this is some
Yes.
value. So this
Yes,
entire
sir.
branch is removed.
Yes, sir.
Sir,
And
is it like
branch
that the source, there will be a current I passing through the source and we don't know anything about different branches?
Yeah,
It is just like that, na? That I will pass through that source and different currents will pass through that 6 ohm and 5 ohm and 3 ohm one.
yeah. Obviously, this different current will pass through here, and this different current will pass through here.
Then we can assign I with that main source only.
Yeah.
Okay, thank you, sir.
So now with this combination, so this is the combination of these two, right? So that means this I, whatever this current I, so both are different. So that's why we cannot apply.
Yes, I got it.
So in continuation of that, so whatever we
Sir,
discussed, that loop current method or mesh analysis, right? So those things, so we can apply here. So those things, so we can apply here. So let us assume that we'll start with loop current method or mesh analysis. Loop current method. So let us assume that you have a source like this. Say this is 6 ohm and this is minus J9 ohm and this is 6 at an angle 30 degrees and this is 11 ohm and this is J5 ohm and this is 7 ohm and this is J2 ohm and this is 8 at an angle 30 degrees. So this is instantaneous plus minus here and this is for this, so this instantaneous plus minus.
Sir, we can assume any direction, right?
What any direction? This is given in the problem. So right, so this is positive, so that means if this waveform is like this, right, at the same time this waveform is like this, that means this is positive, this terminal is positive if you are measured from the other side. Okay, that is the meaning. A particular instant for the particular time period, if this value is positive and that at the same particular time period, so this is the positive terminal, because positive and negative terminals are frequently changing with the frequency, right? It's changing with the frequency, so that's why we have instantaneous directions. So this is the problem. So how we will solve? By using the loop current method or mesh analysis, right? So what is the first thing? So what is the first assumption we use? So
Sir,
identify the number
identify
of
the
Of
loops.
meshes.
Identify
Now how many
currents.
loops are there? 2 loops, right? So this
Two
is
loops, two currents. I1,
this is I1 and this is I2. So what is the next step?
apply KVL on each mesh.
Apply KVL, right? So how to apply KVL? So you have sources one side, right? So this is 6 at an angle 30 degrees. So this is equal to
6I1.
6 minus J9 into I1, right?
I1
Agree? Agree? Plus
plus I1 minus I2,
11
sir.
plus J5. This entire thing is 1, right? 11 plus J5 into,
I1 minus I2.
yeah, good. I1 minus I2. So this is first equation. So what is the second equation?
minus 6 minus 8 at an angle 30 degree.
The current is, right, this is important, right? The current is flowing like this. So that means
I2
current is
minus
flowing like
I1
this,
into
right?
11
The
plus
current is
J5.
leaving the negative terminal. So therefore you have minus 8 at an angle 30 degrees equal to
11 plus
I2
5J
minus I1 into 11 plus
into
7,
J5.
I2 minus I1.
11 plus J5 into
minus
I2
I2
minus
minus
I1
I1.
plus 7 plus J2 into I2.
into I2.
Agree? So what is the next step? So we have to put these things in matrix form. So we need to put these things in matrix form and we have to solve for it. Okay. We need to put these things in matrix form and we can solve for this, right? And we already discussed that by inspection, we can find out the mutual, based on that, we can formulate the matrix, right? So what kind of matrix it will produce? A 2 by 2 matrix, right? You remember, so we have this, so these are, so we have this particular matrix, right? So here you have I1, I2, and here you have voltage matrix. Agree? So this is how you will formulate in a matrix form, right? Clear?
Yes, sir. Yes, sir.
So now tell me, what is the first element? So first element is self-inductance or the self-impedance of the loop 1. What is the self-impedances of the loop 1? So how many elements you have? This is pertaining to loop 1. So this is also pertaining to loop 1, right? So what is the self-impedance? 6 ohm minus J9 plus 11 ohm plus J5. So what is the resultant value?
17 minus
17
4J.
minus 4J.
17 minus
J4.
J4, right? So that is the first element. So what is the next thing? What is the second element? So what is mutual between loop 1 and loop 2? So what is common between loop 1 and loop 2? So this branch, right? Agree? So minus of this branch. So that is 11 plus J5. Agree?
Yes, sir.
So here, so we have this matrix, right? So this is A11, A12, A21, and A22. So what is A21? A12 or A21 both are same, right? So this is 11 plus J5. Agree?
Yes, sir.
So what is A22? Or the self?
Sir, 18 plus J7.
Yeah? Yeah, these two, right?
18
7
plus
plus
J7.
18 plus
18
J7.
plus
18 plus
18 plus
J7.
J7.
7.
Right. So what you will get here? So voltages in this one. So what is the voltage polarity? This is 6 at an angle 30 degrees, right? Agree? And this is minus 8 at an angle 30 degrees. So if you put these things in matrix form, so you will get the same.
Sir,
Yes?
in the impedance matrix, why is it minus of 11 plus J5?
That we already discussed, no, in previous classes. So here this current is with, see here this is. So why particularly minus means, so this is I1 term, right? So this when you multiply, this is I1, right? But when you multiply, this is I2, you need to multiply. So that is how the matrix multiplication will be done, right? Agree?
Oh, okay.
So
Got
that
it,
means
sir.
this is with respect to I2 current. So I1 current is
Okay.
flowing in this direction, but the IT is flowing in the opposite direction. So that's why you have minus sign.
Okay, got it, sir. Thank you.
Similarly, so this is the second one, this is I2, but we are multiplying with I1. So but I1 with respect to loop 2, the I1 is flowing in the opposite direction. So that's why you have minus sign.
Okay,
So for
got it, sir.
mutuals,
Thank
you
you.
have minus sign.
Okay. Thank you, sir.
Yeah, do this.
Sir, can you switch to the previous slide, sir, once?
Just a minute. What's your doubt? Hmm? What's your doubt?
Sir, did you write anything on the RHS side, means
I
right
have
side
written,
of the
no?
equal?
I have written 6 at an angle 30, I think minus 8 at an angle 30.
Okay, sir.
This is the one.
Okay, sir.
This is 4 ohm and this is 20 at an angle 30 degrees, and this is the positive sign, plus minus, and this is 8 ohm, and this is plus minus here, and this is 16 at an angle 70, minus 70, and this is a minus plus, and this is 18 at an angle 35 volts, all are in volts, and this is 8 ohm, and this is minus j 16 ohm, and this is minus j 20 ohm, and this is 18 ohm, and this is 72 at an angle 30 volts, and this is also AC source, this is plus minus, and this is j 12 ohm.
Sir, that is 35 or 33, sir?
Which one?
Uh, Third one, sir.
35,
Third
35 I think.
AC, sir.
35.
Okay, sir.
That is 35 only. So now tell me the matrix. Say this one is I1, right? And this is I2, and this one will be I3, right? So if this is given in polar form, right, you can straight away use capital I1. So this also gives in polar form. So this is also gives you in polar form. This is I2, and this one will be I3. Instead of this 20 at an angle 30, if it is something like 20 sine omega t plus 30, so in that case, use I1, I2, I3. So that is instantaneous values. Okay. So what is the matrix here? So you have I1, I2, I3. This the out. What is the first element? What is the first element?
Twelve plus
12 plus 12J.
Yeah, good. 12 plus. This is
12J.
4, 8. These three are the elements, right?
Yes, sir.
So this one, and this one. What is that? 12 plus J 12, right? What is the second?
sir.
What is common between 1 and 2?
Minus 8.
8.
8, right? So that is minus 8, right? We will write the negative of that.
Yes, sir.
So what is the other common between 1
12J.
and 3?
J12.
So that is
J12 plus
minus
8.
J12, right?
Minus J12. Yes, sir.
Minus J12. So come to the second row. So what is common between 2 and 1? So we have this
8, sir.
matrix, right? A11, A12, A13, A21, A22, A23, A31, A32,
Minus 8 ohm.
A33. What is
Minus
common?
8, sir, again.
Minus
8 ohm.
8.
Minus 8.
Next element,
16 minus 16J.
16 minus J16, right?
Yes, sir.
What is the third element?
Minus 8 again.
Minus 8 ohm.
Plus 8.
What is why plus? Minus again. See, for whatever the mutuals, that are always minus. So these are always minus. Now come to third row.
Minus
Third
J.
row, what is common between 3 and 1?
Minus J.
Minus J12.
Minus J12,
J12.
right? And second element, minus 8 ohm, right? So what is what is the 18 plus 8? So what is 18 plus 8? 26. 26
Minus 8J.
minus 8. Minus 8, right?
Minus 8J.
Minus J8.
Yes, sir.
It's minus 26 or plus 26, sir?
Plus 26 I have written, no?
No. Yes, sir.
Why minus? That is resistance, no? You'll never get that is self impedance, right? You will get only positive values, right? So these are I1, I2, I3. So you are understood, right? Why I have written capital I1? Because so this is given as 20 at an angle 30 form, right? So in that case, I have also used the phasors I1, I2, I3. If it is something like this, so not like something like this, 230 at 230 sine omega t format or cos omega t format. In that case, you have to use small I1, I2, I3. So what is this first value in this? What is the first one?
Angle 30 degrees
20,
minus 16
20 at an
20
angle 30.
30 degrees minus 16 at minus 70 degrees.
20 at an angle 30 degrees minus
Minus 16 at minus 70.
Angle
minus 70
1.
degrees. Yeah, that is the first element. Good. What is the second element?
72 at an angle 30.
You have to follow the order, no? 16 at an
Order,
angle
16 at an
16
angle.
at an angle
70
plus sir.
degrees.
Minus 70.
Plus, sir, plus no.
That is
Plus
plus,
18
right?
at
So here this
plus,
is
plus.
plus, it is leaving at plus, right? So
Yes,
this
sir.
current is leaving
Yes,
at
sir.
plus.
Yes, sir. Yes,
So
sir.
that means you have plus 18 at an angle
18 at an angle
35 degrees.
35 degrees.
What is the
Next
third
one only
one?
72 at an angle 30 degrees.
Minus 72 at
Minus
an angle 30
72
degrees.
at an angle 30 degrees. Good. So you might have studied how to solve these things, right? So you can do that.
In the problem given,
Sir?
16 at the angle minus 70 degrees.
What?
So in the question,
the
sir, you have written minus 70 degrees.
Minus 10.
So this is minus. Okay.
Sir, 1 minute, one doubt, sir.
Yes.
Sir, while solving 20 at an angle 30 means we can consider sine 20 sine omega t plus 30 and we should
So
solve.
no need to bother about that with sine or cos, right? You can subtract these two, no?
How can we separate, sir?
Subtraction of two polar things, you can do that, right?
Oh.
Can we perform these two? You can, right?
So by converting into cos and sine terms.
That you can do straight away in calculator. You can do this. Okay.
Sir, means by using calculator, writing this matrix, we can directly do that.
In calculator, I think this we can do. Okay.
Okay, sir.
Right. Okay.
For exams, can we use calculators? So is it allowed?
You have
for
to
the-
use calculators. So you have
Allowed,
to
right?
use calculators.
Yes, sir. Thank you.
For all the competitive exams, almost all competitive which are related to this electrical engineering, so the calculators are allowed. Even if it is a gate exam or any exam, these calculators are allowed.
Sir, yesterday you have sent one PDF, no, sir.
Yes, yes.
Through that we can prepare and from for minor, sir.
You can use that. Okay, but do not completely rely on the PDF because I told you, some of the portions are missing. Right. So you have to prepare from the class notes only. Okay.
Okay.
So that you can use for additional things.
Sir, is minor descriptive or MCQ, sir?
That I will tell you, no? Okay. So just a minute, the screen is freezed.
Please send to a class notes also, sir.
Yeah. So we will move to the next problem. So for example, you have something like this. So this is 20 cos 4t volts. Right. 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 So you have noted down, right? So what is the first step you need to do? So these are given in henries, right? In farads. So what is the next thing? So you need to convert into its equivalent reactances, right? So what is 1 Henry reactance?
J4, sir, J4.
J4, right?
J4.
Yeah. This I will erase. This is J4. So why J4? This is omega is given as 4, right? 4T. So that is omega. So what is this 0.1 farad?
Minus
Minus
2.5, sir.
Minus 2.
minus J 2.5.
So this is 0.5 means, so this is J2.
J2,
One
yes,
is,
sir.
so one is 4 ohm, J4 ohm. So that means 0.5 is J2 ohm. Okay. What is the next step? So how many loops are there here?
3, sir.
So 3, sir, but
3 loops, right?
common current source.
Sir, excuse me.
Yes.
Sir, is the question supposed to be 1 Henry, 0.1 Faraday, and 0.5 Henry, or we're going to we made these changes for J4? And so when we get the question, will we get in terms of Henry or J?
In Henry only, I think.
It is Henry. It is given in Henry, right? We need to convert in its
Okay.
equivalent reactances
Yes,
by
yes,
using the information of this omega is given, right?
yes, sir.
So based on that, you have to do.
Okay.
So how many currents you have? So how many loops you have? So this is I1, right? And this is I2, and this one is I3. Okay. So if you notice that for I2 and I3, so current source is common, right? For this loop and this loop, current source is common, right? What we have to do when you have common current source?
Super mesh analysis use.
So you need to follow super mesh, right? So you need to follow super mesh. So for first mesh, so what is the current here? So how you apply equations here? So 220 cos 4t, so which is equal to, what is its value? 10 into I1 plus or minus, right? Minus j 2.5 into I1 minus I2. Agree?
Yes, sir.
Agree? So this we can write as 20 at an angle cos t. So this we can write as 20 at an angle 0. So this entire thing we can write as 20 at an angle 0. So later on we do the conversion. Because we consider cos is the reference. So remember, even it is a 20 sine omega t, so we have to consider, so this is 20 at an angle 0 only. So that is our assumption because this cos is the reference. If it is given in sine terms, in that case we assume that the sine is the reference. So what is the equation for this super mesh? So this entire thing will form a super mesh, right? So now tell me, so how many sources are acting this super mesh?
No.
Yes.
Yes. Sir, so why did you write there 20 angle 0 degree?
We are discussing from last 4-5 classes. If it is something like this, sine omega t plus 30, right? So how we will write this? 20 at an angle 30 degrees, right? Agree?
Yes, sir.
Okay. Similarly, you have 20 cos omega t plus somewhere 15 degrees. How we will write this? So this is also, if this is individual, right? If this cos is the reference, so this we can write as 20 at an angle 15 degrees. So here the sine is reference and the cos is the reference. So this is for making this calculation simpler. Okay.
Yes, sir. Yes, sir.
So I will
But
tell
why
you,
over
so how
here
the
we have
current will be, how the current format will be, right? So once you solve the problems, you will understood, right? So how to apply this super mesh KVL equation?
sir? So here how we got 20 at angle 0 degrees. So how did we get 0 degree over here? Kind of
So there
confused.
is no angle right here.
So whenever there is no omega t plus angle, then we just take it as 0.
Obviously. So this is in the format 20 cos 4t plus 0.
Okay, yes, I got it.
Sir, but that is cos function. Now we need sine there to convert
See here,
sine.
I said you right. So you can take this entire exercise we are doing in cos as the reference.
Okay, sir.
Okay, reference is cos here. So I already told that the reference is cos. If it is sine, so we also assume that it is 20 at an angle 0. This simplifies the calculations. Okay, so you cannot solve these equations with cos terms, right? So this is 20 at an angle 0. So for example, right, for example, you have calculated the current I1. So I1 you got something like 33 at an angle minus 20 you got, right? So how you will express this I1? So I1 you got like this. So how you will express this I1 here? So this you assumed as 20 at an angle 0, right? So how you assume this 30 at and 33 at an angle minus 20 degrees? So this is magnitude 33 cos 4t minus 20 degrees. Agree? It's clear?
Understood, sir.
If the end answer is I1 at an angle 33 at an angle minus 20, for assume that, right? So here we assume that 20 cos 4t is 20 at an angle 0. So that means this will be 33. So cos is the reference. Cos 4t minus 20. That is the answer. Okay. So now tell me the super mesh equation. So how to write this equation?
J into 2.5, I2 minus I1.
J4 into what is the current?
I2, sir.
I2. Right. Plus this element
I3 into J2.
J2,
I3
sir. Yes, sir.
plus
J into 2.5, I2 minus I1. Sir.
minus
minus J into 2.5.
minus J 2.5
J into
I2 minus
2.5.
I1.
I2 minus I1. So entire thing is equal to what is the entire thing? Zero, right?
0.
So there is no voltage sources. So now tell me this equation. So this is current source equation, right?
I3
sir,
minus
plus J
I2
2.5,
equals to
sir.
2x.
I3
Sir, I3 minus I2 equals to 2 of I1 minus I2.
2 into Ix, right? So what is Ix? What is Ix?
I1
This is
minus
Ix,
I2,
right?
sir.
I1 minus I2, sir. I1 minus I2.
I1 minus
I1
I2.
minus I2.
Sir,
Yes.
doubt, sir.
Yes.
Sir, in the equation, the Ix is flowing to the opposite direction we have taken, so we have to consider plus, no, sir, plus J 2.5.
This is Ix, right? You can't change this. So this obviously this I1 it is flowing like this.
Ix is
and
correct,
I2 is
sir.
flowing like
The
this.
direction we are taking, it is opposite to that of Ix, no, sir.
Why opposite?
Ix is flowing downward, but the direction we are taking is upward, near that minus J into
So
2.5.
here there are two currents that are flowing, right? So in this element there are two currents that is flowing. One I1 is flowing in the downward direction, I2 is flowing in the upward direction, right? But the given one is Ix is like this, right? So that means I1 minus I2.
Not that equation, sir. Above one, sir. Above one. I
This
understood
one.
that one. Sir, J4 into I2.
So
In that
this is the
equation,
one, right?
Sir. In that equation, we have to consider plus J 2.5
So this
into
is the
I2 minus
reference, right? For this is the reference for writing the super mesh equation.
Yes, sir.
Okay. So obviously it is I2 minus I1 only. See here in this capacitor you're talking about, right? So this I2 is flowing like this and I1 is flowing like this, right? Agree?
Okay, sir. I understood, sir. I understood.
But the super mesh is found between these two only, right? So with respect to this, we are writing.
Okay, sir. Okay, sir.
Okay.
Okay, sir.
So these are the equations. So these are the equations. So from solving these things, what Ix is got as, for example, Ix, I have answer for this. So this is 7.59 at an angle 108.4 amperes. Okay. So this is Ix. So how you write in its actual form? How you write in this actual form? In this form? How you will write this?
7.59.
7.59
Cos omega cos 40 plus
cos 40 plus
108.4.
108.4 degrees.
108.4 degrees, right? Agree? If this is sine, so this is also sine. That's it. Okay, so that is the how you consider reference things. Because if you use this cos terms, it is difficult to solve the equations, right? So you need to assume that this is the polar form.
So this Ix value after doing all the previous calculations we got, right?
Yeah, obviously.
Yeah, obviously.
So this is how you will solve. So when you have what we have when you have so what we say the dependent source is there and we have to apply the super mesh. So we have another problem. Solve this. So this is 12 ohm, and this J6 ohm, and this is 4 ohm. This is minus J3 ohm, and this is 3 at an angle 0, 3 at an angle 0, and this is 4 ohm, and this is 10 at an angle 45 degrees. And here you have the plus sign, plus minus.
What's it written over there, sir? 10 at an angle 45 degree?
Yeah, 10 at an angle 45 degrees. No, we are doing, sorry. You can leave this, and this is when you have to use this when you are using the nodal analysis. Okay. Okay, we'll start nodal analysis. Okay, there's nothing wrong in it. So now we move to nodal analysis.
Can't we solve this by using mesh analysis, sir?
Yeah, you can do it, but this one is formed by, if you notice that, so there is a super node is there, right?
Yes, sir. In that 10 at the 45 degrees is a super node.
Let's keep it one example. Okay, no problem. We are already aware of these things, right? And directly skip it, no problem, right? So we are using this nodal analysis, and we had to solve this particular kind of problems. Okay, so this is the reference node, right? So what is the next step? You need to identify the nodes. So how many nodes we have here?
So 2 nodes.
Excluding the reference, right?
nodes,
So this one will be the V1 and this will be V2. Agree?
Yes, sir.
So this is V1 and this is V2. So what is the next step?
Apply KCL on each node.
So apply KCL. Right. So apply KCL. So how to apply KCL here? So here if you notice that we have super node here, right? So here between V1 and V2 we have voltage source. Have you seen that? Mm-hmm.
Sir, then V1 minus V2 equal to 10.
Yeah, we have equation V1 minus V2 equal to 10 at an angle
10,
45.
45.
So we have to be careful with this. This is plus sign, right? And this is minus sign. So that's why V1 minus V2 equal to 10 at an angle 45 degrees. That is the first equation, right? So how to write the second equation? So you cannot apply KCL here and you cannot apply KCL here, right? So what you have to do is we need to formulate entire this thing as a super node. So that means it will be like this. Right. So with this entire thing is a super node. So this is V1 and this is V2. 3 at an angle 0. So this is minus J3 ohm and this is J6 ohm and this is 12 ohm. Right. So if you notice that, so this 4 ohm is in parallel with the super node, right?
Yes, sir.
You notice that. So that means this is, there is no value for that. So that means this is also included in the super node. So we are assumed that the V1 and V2 are at the same potential. So that means there is no current that net current that flowing, right? So that is 4 ohm only. Clear? So now how to write the super node equation?
So 3 at an angle 0 degree.
This is the current, 3 at an angle 0 degrees. And this one, if you assume this is the current direction, how you will write?
So V1 upon minus J 3 ohm.
3 ohm, right? So next this is the direction and this is the direction. How you will write? plus V2 upon J6. Agree?
J6. Yes, sir.
Yes, sir.
Plus V2 upon 12. So which is equal to 0. No.
Sir, I think
Sir,
all are negative signs, sir.
This is
This
this
whole
is
is
incoming
equals to
current,
3
right?
at
So
angle
this is
0
3
degrees,
equal,
sir.
this is equal
Yes,
to
sir.
this. So now the question is, so why we are not considering this 4 ohm? So because this 4 ohm is common to V1 and V2, so if we consider or if we apply super node here, so this one is V1 minus V2 by 4. Agree? Agree?
Yes, sir.
So when you are considering this is the current, so in this case, so it is V2 minus V1 by 4.
0.
So because this is also, this entire thing is 0, right? So that's why we opted out. Understood?
Sir, could you repeat that bit? Like V2 minus V1 by 4.
So here, so this is with respect to V1, right? Okay. So this current is, what is the current that flowing is V1 minus V2 by 4. Agree?
Yes, sir.
So here, so when you write this V1 minus V2 by 4, this is one element, right? With respect to this, so it will be V2 minus V1 by 4. Clear? So that's why these two will be cancelled. So that's the entire thing. So what we did is we removed that 4 ohm. Even though we are writing the KCL equations, the current is 0. In other words, both will be cancelled.
Okay, sir. Got it. Thank you.
Got it? Okay, so we'll move forward to the other problem. So this is 0.5 ohm and this is 0.4 ohm. This is 16 at an angle 45 degrees. And this is J 0.5 ohm. And this is minus J 0.8 ohm. And this is like this. This is 2Ix. Okay. Where is Ix? So this is Ix.
This one looks similar to that of the previous problem, sir.
Mhm.
In the mesh, super mesh.
Yeah, but numbers are different, no?
Only numbers are different, sir. Model is
Okay, no problem. So you have to use the nodal analysis. By using nodal analysis, you need to solve this problem. So how many meshes? Sorry, how many nodes you have? How many nodes you have?
Sir, including reference
Three.
node, 3 nodes.
Including
Three,
reference
sir.
3, right? So this is the reference. So label this as numbers. So it is V1 here and V2 here. Agree?
Yes.
What is the next step?
Applying KCL.
Apply
There
KCL.
is no voltage source that are common between any nodes, right? So apply KCL. So here, so what is, if you assume this is the current, so what is the current here in this 4.4 ohm resistor? So no, I forgot to give the polarity. This is plus minus. Okay. So what is the V1 here?
V1 minus.
So what is the current here? This current?
So V1 minus 16
So
at an angle
V1
minus
minus
45 degree
16 at an angle minus 45 divided by
upon
0.4, right?
0.4.
So this current, what is this current?
V1 by J
upon
J
minus 0.
0.5 ohm.
0.5 ohm, right?
Yes, sir.
So next, what is the other current? This current, if you assume this is the direction,
V1 minus V2 upon
V1
minus
minus
J
V2
point
upon
eight
V1 minus V2 by minus J
0.8 ohm.
minus J
point
0.8.
8 ohm.
This is equal to 0, right?
0.
Yes,
Okay.
sir.
So this is equation 1. So come to second equation. Second equation. So how to start that? If you assume that this is the direction, so in that case,
V2 minus V1 by
V2 minus
minus
V1
V1 by
minus J
minus
point 8 ohm.
okay, plus. So this
V2
one, this
upon
is
0.5.
incoming current or
V2 by
outgoing current?
0.5
So this is incoming
V2
current,
upon
right?
0.5.
So 2 into Ix. Agree?
Yes, sir.
plus V2 by
Plus
0.5.
V2 by
V
0.5.
0.5.
So how to write this is equation 2? So how to write Ix? What is Ix? Ix is the current
V1
in
upon
J0.5.
J 0.5.
So V1 upon J 0.5.
J 0.5.
So this is equal to V1 upon J 0.5 into 2, right? 2 into V1 upon J 0.5.
Yes, sir.
So what is the rest of the things? You need to formulate or you have to put this in matrix form and you need to obtain for, yes?
Sir, why have you considered at minus J into 0.8? It's outgoing current, sir. It can flow like this, sir, towards 0.5.
Which one you're talking about?
In the second equation, sir, second equation, V2 minus V1 by minus.
See here, I have assumed this is V1, this is the one. Okay, this is the one. So we've already discussed in
How
several
can it flow,
times.
sir? It can be like this, sir.
See here, we already discussed this, right? So if this is the, if you assume this is the already given direction, so in that case, it will be V1 minus V2 by minus J 0.5 and it should be come on the right hand side because it is an incoming current. Okay. Or if you take a fresh notation, this is like this. So this will be the outgoing current. This is also outgoing current. So that means V2 minus V1 by minus J 0.5. This is the first term. And this is V2 by 0.5. This is the second term. And this is the incoming current, right? This is already given. So this is 2 into Ix. Okay. Simple thing. If we assume or if we use the same direction, in that case, it will be on the incoming current values, right? If we assume, if we take a new things, in that case, it will be on the outgoing current direction. So the result is same. No confusion, right?
No confusion.
So any questions here?
No, sir.
So I think we've almost covered all the problems. We covered mesh analysis. So when you have dependent sources, so what we have to do that we discussed. And when you have super mesh, that also we have discussed. And this node voltage method. So when you have dependent sources that we discussed. And if we have common node, so that is super node, so that also we discussed, right? So more or less we covered all the scenarios. So you're aware these things, right? You're already aware of applying this loop current method and this node voltage method. So when you're using the DC circuits, the same implies here. The only difference is it is slightly complicated. Okay, it is slightly complicated because of these J terms. Solving is also slightly complicated, right? You have any questions? You have any questions?
Sir,
Yes.
will we be getting questions like this in the exam?